Across the unfathomable darkness of interstellar space, a traveler journeyed. For millions of years, it moved unseen, a silent pilgrim between the stars. It wasn't until December 28, 2019, that our vigilant eyes on Earth finally caught a glimpse. The Asteroid Terrestrial Impact Last Alert System, or ATLAS in Hawaii, spotted a faint, fuzzy object moving against the background of distant stars. At first, it seemed like just another comet. But as astronomers plotted its path, a stunning realization dawned. This visitor, designated 3I Atlas, was not from our solar system. It was an emissary from another star, a ghost from the interstellar deep, paying a fleeting visit to our cosmic neighborhood. This was only the third interstellar object ever detected, following Oumuamua and 2I Borisov. But 3I Atlas was different. Unlike its predecessors, it seemed to be a primordial relic, a fragment of a planetesimal from the dawn of another solar system, cast out into the void billions of years ago. It carried with it the chemical secrets of its birthplace, a time capsule from an alien world. As it drew closer to our sun, the gentle warmth began to stir the ancient ice within its core. What secrets was it about to reveal? The world's most powerful telescopes, from the ground-based giants to our sentinels in orbit, turned their gaze toward this mysterious wanderer. The race was on to decipher its message before it disappeared back into the endless night. As 3I Atlas hurtled toward the sun, its behavior grew increasingly strange. Telescopes like the Hubble Space Telescope captured astonishing images. Instead of a single solid nucleus, the comet appeared to be breaking apart. It wasn't a violent explosion, but a gentle, almost graceful disintegration. First, a large fragment calved off, followed by smaller pieces, each piece glowing with its own hazy atmosphere, or coma. It was as if the comet was dissolving, piece by piece, as it felt the sun's heat for the first time in its long, cold existence. This fragmentation offered a unique, unprecedented opportunity. It was like peeling an onion, layer by layer, allowing us to see inside a body that had formed around a star light years away. What could cause such a breakup? One theory points to its rapid rotation. As the sun's energy vaporized its ices, the escaping jets of gas could have acted like tiny rocket engines, spinning the comet faster and faster until centrifugal force tore it apart. Another possibility is that the comet was never a single, solid body to begin with. It might have been a loose rubble pile, a collection of smaller icy chunks held together by weak gravity, which simply couldn't withstand the thermal stress of its close solar pass. Whatever the cause, this celestial drama was unfolding right before our eyes, a cosmic spectacle billions of years in the making. The fragments continued their journey, a ghostly procession trailing through our solar system, each one a clue to the comet's origin and composition. The true magic of 3I Atlas lay not just in its structure, but in the chemicals it was releasing. As the sun's ultraviolet radiation bathed the comet's fragments, it triggered a cascade of chemical reactions. The gases boiling off the icy nucleus began to glow, creating a beautiful, ethereal coma. Spectrographs, instruments that split light into its constituent colors, were our key to unlocking the comet's chemical code. NASA's Neil Gehrels Swift Observatory, designed to hunt for gamma-ray bursts, turned its powerful ultraviolet telescope towards the comet. It detected something remarkable, a significant amount of water ice sublimating, turning directly from a solid into a gas. The sheer volume of water vapor was staggering, far more than what was seen from Comet Borisov. This told us that 3I Atlas was rich in water, a fundamental ingredient for life as we know it. But the story didn't end there. Further analysis revealed the presence of other key molecules. Carbon monoxide and carbon dioxide were also abundant, trapped in the ancient ice. The ratio of these compounds provides a chemical fingerprint, telling astronomers about the temperature and conditions in the protoplanetary disk where the comet was born. For 3I Atlas, The chemistry suggested it formed in a very cold, distant region of its home star system, much like the comets in our own Oort cloud. It was a tantalizing piece of evidence, suggesting that the processes which form planetary systems might be more universal than we ever imagined. Imagine a vast swirling disk of gas and dust surrounding a newborn star. This is a protoplanetary disk, the birthplace of planets, asteroids, and comets. Within this cosmic nursery, tiny grains of dust and ice begin to stick together. Through a slow, patient process of accretion, they grow from microscopic particles into pebbles, then boulders, and eventually into massive planetesimals, the building blocks of planets. Our own solar system formed this way, and the comets in our Oort cloud are the leftover frozen remnants from that chaotic era. They are pristine samples of the primordial solar nebula. The data from 3I Atlas suggests it followed a similar path, but around a different star. By studying its composition, we are essentially performing an archaeological dig on an alien solar system. The relative amounts of water, carbon monoxide, and other volatiles act like a thermometer, telling us about the environment in which it formed. The fact that its composition is so similar to our own long-period comets is profound. It hints at a universal chemistry, a common recipe for building solar systems across the galaxy. It suggests that the same raw materials that led to the formation of Earth, and ultimately to us, may be scattered liberally among the stars. 3I Atlas is not just a rock, it's a message in a bottle, confirming that the story of our origins may not be unique. As quickly as it appeared, 3I Atlas began its long journey back out of our solar system. Its path, a graceful hyperbola, is carrying it away from our sun, never to return. Its fragments, now faint and diffuse, are receding into the darkness from whence they came. But the data they left behind will be studied for years, even decades. Future missions like the James Webb Space Telescope and the upcoming SPHEREx observatory are designed to hunt for more of these interstellar visitors. SPHEREx will scan the entire sky every 6 months, creating a vast celestial map and searching for the faint signatures of water and other organic molecules that might betray the presence of another interstellar guest. Each new discovery will add another piece to the puzzle. Are most interstellar objects rocky like Oumuamua or icy like Borisov and Atlas? Do they all share a similar chemical makeup? Or will we find exotic compositions that challenge our understanding of planet formation? These are the questions that drive us to keep looking up. These interstellar objects are the only tangible pieces of other star systems we can currently study directly. They are precious samples delivered right to our doorstep, offering us glimpses into the vast diversity of worlds that populate our galaxy. The legacy of 3I Atlas is the confirmation that we are connected to the wider cosmos in ways we are only just beginning to comprehend. The story of 3I Atlas is a powerful reminder of the dynamic and interconnected nature of our universe. It shows us that star systems are not isolated islands. They exchange material over vast timescales. It's conceivable that billions of years ago, comets from our own solar system were flung out to visit other stars, perhaps carrying the same chemical building blocks of life. We live in a galaxy where the remnants of creation are constantly on the move, weaving a complex tapestry of cosmic history across light years. The discovery of 3I Atlas and its companions has opened a new frontier in astronomy: interstellar archaeology. We are no longer limited to studying our own cosmic backyard. The universe is sending us samples, and we are finally building the tools to read them. The journey of this one small, broken comet has expanded our horizons and reaffirmed that the quest for knowledge is as boundless as space itself. Thank you for joining us on this incredible journey to the edge of our solar system and beyond. The universe is full of wonders, and with each new discovery, we learn a little more about our place within it. If you enjoyed this exploration of interstellar mysteries, please consider liking this video and subscribing to our channel for more deep dives into the cosmos. Let us know in the comments what cosmic topic you'd like to see next. Until then, keep looking up.